Welcome to my class. I'm Drew Collop. Today's class will be a continuation of our conversion factor lectures. Previously, we talked about metric conversions, then we did rate and exponential conversions. Now we'll talk about volume and density conversions. Please note, volume represents the amount of three-dimensional space a substance takes up. For all substances, 1 centimeter cubed is 1 milliliter. In a previous lecture, I spoke about some television programs, mainly those ones concerning emergency rooms, where a doctor will yell, "Give me 4.8 cc's of adrenaline stat." What they're really saying is, give me 4.8 mils of adrenaline as soon as possible. So if you can remember that, cc's is cubic centimeters, but we don't write it as cc's, we write it as centimeters cubed. That is actually the definition of what 1 milliliter is. It's the amount of three-dimensional space taken up by 1 centimeter cubed. That's 1 milliliter. Hopefully you can remember this by thinking about the syringes. cc's is milliliters. Actually, you can see it written on the syringe right there. So this would be 4.8 cc's, which is 4.8 milliliters. Now that is for all substances. This is true. 1 centimeter cubed is 1 milliliter. When we're dealing with pure water, 100% water, as we spoke about, for all substances, 1 centimeter cubed is 1 milliliter. But for pure water, that's also equal to 1 gram. So this would also be good values to commit to memory. Now remember, anytime two things are equal, I can use those as conversion factors. Therefore, by knowing this, you will know all these conversion factors for all substances, how to convert from milliliters to centimeters cubed, and for water specifically, how to convert between centimeters cubed, milliliters, and grams. Density is a parameter where we measure grams to milliliters. For water, we usually state it's 1.0 grams per mil. You can see this is relating your grams per mil. I've also shown you a graph right here. Density on my vertical axis and temperature on my horizontal axis. Notice what happens here with water, one of those unique things with water. This part of the graph is above 0 degrees, above freezing. This value here represents that 1 gram per mil. Our units are different, kilograms per meter cubed, but if you converted that over, that would convert over to grams per milliliter. You can see from 0 to 100 degrees Celsius, there's not a whole lot of change in that. So that's why we usually just refer to water as being 1 gram per mil. The issue is when you freeze water. Look at this. When you freeze water, what do you notice? The density changes. We're now down here. This is a very important parameter of water. The density is lower. As a result, when water converts to ice, it is less dense. The density goes down. This means ice floats on water. Without this feature, all of our lakes would freeze from the bottom up. And who knows, life as we know it may not even exist. So the fact that the density of water changes when it freezes is a very important feature of life. In fact, on planet Earth, wherever there is water, no matter the temperature, life is always found, which is why it's so exciting when we find water on other planets. Because on Earth, wherever there's water, there's life. Now let's do some conversions involving density and pure water. Example number 1, convert 5 centimeters cubed to milliliters. So 5 centimeters cubed, write down what we're given. We're going to convert from centimeters cubed to milliliters. And remember, for all objects that exist, 1 centimeter cubed is 1 milliliter. Because these things are equal, I can use those as conversion factors. Centimeters cubed cancel centimeters cubed, and I'm left with 5 milliliters. As you can see, 5 centimeters cubed equals 5 milliliters. However, on any assessment, you must show me your work. You must show me how you got from centimeters cubed to milliliters. If not, you're going to lose marks. Example 2 is a bit different. We're taking 4.26 centimeters cubed and we're going to liters. As these conversions get more difficult, I would like you to draw a game plan. So the game plan here, I'm going to take centimeters cubed and I want to go to liters, but I have to go to milliliters first. So my game plan is centimeters cubed to milliliters to liters. And each of these arrows represents a conversion factor. So for all objects, 1 centimeter cubed is 1 mil. And we use our metric conversions. We put milliliters on the bottom, liters on the top. 1 liter is 10 to the 3 mils. We cancel out centimeters cubed. We cancel out milliliters. We're left only with liters. Let's now work this out. 4.26 times 1 over 1 is just 1, times 10 to the minus 3 liters. This is improper scientific notation. Therefore, that is the final answer. So understanding that 1 mil is 1 cubic centimeter, we can switch between cubic centimeters and milliliters or liters. Let's now look at example 3. For a sample of pure water, that is a very important wording in there. Convert 5 centimeters cubed to milligrams. So 5 centimeters cubed. What's my plan? I'm starting at centimeters cubed. I want to go to milligrams. I know for pure water, 1 centimeter cubed is 1 gram. After I'm in grams, then I can go to milligrams. Let's work this out now. Go from centimeters cubed to grams, 1 and 1. This works because this is pure water. This only works for pure water. So this conversion factor right here is referring to the density of pure water. Later on, we'll have another lecture on density, and we'll talk about the densities of other chemicals. But for pure water, 1 centimeter cubed is 1 gram, which is 1 mil. Move that over. We then add in our next conversion factor. We're going to go from grams to milligrams. 1 gram is 10 to the 3 milligrams. Cancel out my units. I'm left with 5 times 10 to the 3 milligrams. Final answer. So remember, for pure water, the density is 1 gram over mils, which is the same as saying 1 gram per cubic centimeter. This is for pure water specifically. Let's try some practice problems involving cubic centimeters and milliliters and potentially pure water as well. This is practice 4. Again, this is a continuation of our other conversion factor lectures. 4A, B, C, and D. Notice in some of these, the word pure water is there. That is very important. Give these a try, and because I think it's so important, I'll take them all up. But make sure you try these on your own first. See where your mistakes are so you can learn from those mistakes. Let's take these up. 5.92 milliliters. So my plan here, milliliters, I want to go to meters cubed, so I can go from milliliters to centimeters cubed, and then I can go to meters cubed. Notice here, I'm not only converting from milliliters to centimeters cubed, but I'm also going to have an exponential conversion. So let's do that now. Milliliters on the bottom, centimeters cubed on the top. For everything that exists, 1 centimeter cube is 1 mil. That is actually the definition of what a milliliter is. I will then convert centimeters on the bottom, meters on the top. 1 meter is 100 centimeters, but it's cubic units, so I will cube the top and I will cube the bottom. This will then give me 5.92 milliliters times 1 centimeter cubed divided by 1 mil multiplied by 1 meter cubed over 2 times 3 is 6 centimeter cubed. Mils cancel mils, centimeters cubed cancel centimeters cubed, meters cubed is what I was asked for. 5.92 times 10 to the minus 6 meters cubed. Final answer. Next up, I'm taking 234 decimeters cubed and I'm going to deciliters. So my plan here, I'm going to start at decimeters cubed, go to centimeters cubed, then I can go to milliliters, then I can go to deciliters. Let's do that now. Here we'll go from decimeters to meters, and then meters to centimeters. 1 meter is 10 decimeters, and 1 meter is 100 centimeters. Now remember, these are cubic units, so I have to cube both the top and the bottom. I will then have it in centimeters cubed. Centimeters cubed on the bottom, mils on the top, 1 and 1. Go from milliliters to liters. 1 liter is 10 to the 3 milliliters. And then we will go from liters to deciliters. 1 liter is 10 to the 1 deciliters. You can see these are getting quite large. 234 decimeters cubed, 1 meter cubed, 10 to the 3 decimeters cubed, 10 to the 6 centimeters cubed, 1 meter cubed, okay, let's cancel out units. Decimeters cubed, decimeters cubed, meters cubed, meters cubed, centimeters cubed, centimeters cubed, milliliters, milliliters. Oh, forgot my unit there. Liter right there. Liters and liters, leaving me with deciliters. Exactly what I asked for. Now we'll do the numbers. 10 to the 3 comes up to the top, becomes minus 3. 1 divided by 1 is just 1. 10 to the 3 comes up to the top, becomes minus 3. Collect all those bases of 10. Negative 3 plus 6 is positive 3. Minus 3 is 0. Plus 1 is 1. Deciliters. This is not proper scientific notation. I had to divide this one by 100, so I have to multiply this by 100. Gives me 10 to the 3 deciliters. Final answer. You can see a lot of steps along the way. This is only going to get more challenging as we move on, which is why I would encourage you to write this plan in place so you don't get lost. Now here we have 2 problems involving pure water. So for pure water, 1 cubic centimeter is equal to 1 mil. That's for everything. But for pure water, it's also equal to 1 gram. So this is specific for pure water. This part is everything that exists. We want to go from 6.2 liters to grams. So what's my plan? I'm going to go from liters. If I have pure water, I can go from milliliters to grams. So I'm going to go from liters to milliliters, and then I'll go to grams. There's my game plan. So liters to milliliters, 1 liter is 10 to the 3 milliliters. And over here, 1 milliliter is 1 gram. Again, this is specific for pure water only. Milliliters cancel milliliters, liters cancel liters. I'm left with grams as my units. 6.2 times 10 to the 3 grams. In proper scientific notation, therefore it's the final answer. One more problem involving pure water. we have 8.98 meters cubed. I want to go to kilograms. So what's my plan? Starting with meters cubed, I want to go to kilograms. This is pure water. So if I can get that to centimeters cubed, then I can convert to grams, and then I can convert to kilograms. Let's do that now. Meters on the bottom, centimeters on the top. 1 meter is 100 centimeters, but it's cubic units, so I got to cube the top and the bottom. Next up, I'll have it in cubic centimeters. I can go to grams for pure water. 1 gram is 1 cubic centimeter. Again, this is because it's pure water. Then we'll go from grams to kilograms. 1 kilogram is 10 to the 3 grams. Here we get 8.98 meters cubed multiplied by 2 times 3 is 6 cubic centimeters over 1 meter cubed. Multiply this by 1 gram over 1 cubic centimeter. Multiply this by 1 kilogram over 10 to the 3 grams. Cancel out units. Meters cubed, centimeters cubed, grams, grams. Kilograms is what I get, and that's what I asked for. Combine those together. 6 minus 3 is 3. 8.98 times 10 to the 3 kilograms. Final answer. So you can see by understanding a few things, such as 1 cubic centimeter is 1 mil, and for pure water, 1 cubic centimeter is 1 mil, and those are both equal to 1 gram. By knowing those things, you can do some calculations quite quickly. The second part of this lecture, we'll talk about converting non-SI units. So those SI units, those are the units we use in science. Meters, grams, liters. Some places, they still work in other units. These are non-SI units, specifically the United States. Quite often when you're working with people from the United States, you'll have to do conversions. Now, thankfully, their scientists work in SI units, but the general population does not. Let's look at some of these units. So for mass, we have atomic mass units. This is when we're dealing with atoms. For mass, we have ounces. That's equal to a certain number of grams. We have pounds. Stone, that's a British notation. Now notice this. We have ton, but we have a US ton and an imperial ton. Notice it's 2 different values. So be careful of that. When someone says there's a ton of something, are you talking US or imperial? For length, we have inches, feet, yards, miles, and AU, astronomical units. This is the distance between Earth and the Sun. Now for length in SI units, we work in meters. For mass, we work in grams. For volume, we work in liters, but there are gallons. But notice there's also imperial and US, and they are different values. So make sure you get clarification. We have quarts, we have pints, we have cups, we have fluid ounces. So that's confusing. You have fluid ounces and you have ounces. One is mass and one is volume. In chemistry, you'll work with some other values. Atmospheres, kilopascals, torrs, psi. In time, notice these are all exact values. 1 minute is exactly 60 seconds. 1 hour is 60 minutes. 1 day is 24 hours. 1 year is 365 days. And 1 week is 7 days. For some reason, students, when they're working with a year, they think this is going to be 52 weeks. It's actually incorrect. If you actually look at a calendar, there's not 52 weeks in a year. There's about 52 weeks. So we don't use 52 weeks in a year. Also, I put on here 1 acre. What I would recommend is printing off this sheet and having it as a resource. That way you don't have to look it up. It can be very confusing, which is why in science, when we work with mass, we work with grams. Length, meters. Volume, milliliters. Pressure changes depending on who you're working with. Normally you're working in kilopascals, but in some of your calculations in chemistry, you have to work in torrs or in atmospheres. And time is here as well. One final thing I want to point out. I'm going to highlight some values here. Those values in green I've highlighted, these are all exact values. What does that mean? It means there's an infinite number of significant digits on there. So when doing calculations using conversion factors, sometimes you'll have to round. The other values, they are measured numbers. So there will be a certain number of significant figures in them. However, the values in green, those are exact numbers. One other thing I want to point out, technically a year is not 365 days. Technically it's 365.25, which is why every 4 years we have a leap year. However, for calculations, we will use 1 year is 365 days. Also for temperature, we have Kelvin, degrees Celsius, and Fahrenheit. Now quite often, when you're working with calculations, your temperature will be in Kelvin. To solve these, there is no easy conversion factor. There are calculations you must do. For instance, what would 0 Kelvin be? Set that equal to 0. Solve for degrees Celsius. So 0 Kelvin is minus 273.15 degrees Celsius. Please note, space is not 0 Kelvin. 0 Kelvin is actually just theoretical. Many people have tried to lower the temperature of things to 0 degrees Kelvin. There's actually been many deaths by things imploding and then exploding. If you want to do some extra reading, read about people trying to get down to 0 Kelvin. So we have one formula for converting between Celsius and Kelvin. We have another formula here for converting between Fahrenheit and Celsius. I want to ask you a question. Here we have a thermometer. And we have our liquid inside, and it goes up. Based on temperature, if we increase the temperature, it increases the volume. Why does water boil at 100 degrees Celsius? And why does it freeze at 0 degrees Celsius? That seems super convenient. How is that possible? Take a moment and think about that. Here's your answer. They just made it up. They measured the temperature, and when water froze, they put a line there and they said, that's 0 degrees Celsius. When water boiled, they put a line there and they said, that's 100 degrees Celsius. And then they divided up the scale between 0 and 100 times. Let's now try some practice problems where we are converting some of our non-SI units into SI units. As in many of our scientific calculations, those units must be in SI units for them to work. Let's try example 4. 16 inches converted to centimeters. 16 inches. Now I want to get rid of inches. I placed on the bottom. I want to convert to centimeters on the top. So I have to find a situation where those two things are equal. Let's go up to our chart. Centimeters and inches. Right here. 1 inch is 2.54 centimeters. So we'll use this as our conversion factor. 1 inch is 2.54 centimeters. Do the math. Inches cancel each other out. 16 times 2.54, 40.64 centimeters. Now here we have to work with rounding off. Again, we said 1 inch is equal to 2.54 centimeters. Couple things here now. This, as I stated earlier, is an exact number. This is a measured number. How many significant digits in a measured number? Well, this one will have 3. How many significant digits in an exact number? There's an infinite number of significant digits. How many digits here? There is 2. So when we're rounding this off, what do we round to? Well, we round to 2 significant digits, approximately equal to 41 centimeters. So make sure you take that into account, the fact that sometimes these values in your conversion factors are exact numbers. Let's try the next one. 56 grams. So I want to go from grams to ounces. Let's go check that out on our chart. Grams to ounces right here. 1 ounce is 28.3 grams. 1 ounce is 28.35 grams. Now remember, this is an exact number. The other number is a measured number. So we will use this as our conversion factor. Grams on the bottom, ounces on the top. Grams cancels out grams. I'm left with ounces. Now significant digits. I have 2, I have 4, I have infinity. So I'm rounding this off to 2 digits. So this is approximately equal to 2.0 ounces. Notice I need to have that 0 there because it has to be 2 significant digits. Don't forget that. Let's try example 6 together. So I'm going from 1,200 milliliters to US gallons. Notice it says US gallons as opposed to imperial gallons. We're looking at this value right here. 1 US gallon is 3.785 liters. 1 US gallon is equal to 3.785 liters. Now notice I have to do one extra step here. I have to convert first from milliliters to liters. And then I can use that conversion factor. 3.785 liters on the bottom, 1 US gallon. Mils cancel mils, liters cancel liters, left with US gallons. 1,200 times 10 to the minus 3 divided by 3.785 US gallons. Work this all out. Significant digits now. I have 2 exact numbers, exact numbers, exact numbers, 4. So notice these are all exact numbers. As a result, I'm going to round this off to 2 significant digits. 0.32 US gallons. Example 7. Convert 4.2 years to minutes. What's my plan now? Going to go from years to days, from days to hours, and hours to minutes. Now please note, on any assessment I give you, I will give you a reference sheet with these values on there. Except I won't give you the time conversions. I'll expect you to know these. 4.2 years. I want to convert from years to days, and then from days to hours, and then from hours to minutes. 1 year, 365 days. 1 day, 24 hours. 1 hour, 60 minutes. Years cancel years, days cancel days, hours cancel hours. I'm left with minutes. 4.2 times 365 times 24 times 60. Round this off to the appropriate number of significant digits. These are all exact values. As a result, we only have one value that is measured. So this will round to 2 significant digits. Let's put it in proper scientific notation. 2.2 times 10 to the 3/6. 2.2 times 10 to the 6 minutes. Now ask yourself, does that make sense? In 4.2 years, how many minutes are there? There's a lot of minutes. So that makes sense. Be careful. I see many a student doing things like saying there are 24 days in an hour or 60 hours in a minute. Double check your work. We have a number of practice questions here. Again, this is practice 5 as we're continuing on from our last 2 lectures. 5A, B, C, D, E, and we have F. Give these a try, and because I think they're so important, I'll take them all up. Let's take them up. 345 pounds. Now, I'm going to go from pounds to grams using my conversion factor chart at the beginning, and I'm going to go from grams to kilograms. 1 pound is 453.6 grams, and 1 kilogram is 10 to the 3 grams. Pounds cancel pounds, grams cancel grams. Significant digits now. Exact number, exact number, exact number. I have 3 and I have 4. So I'm going to round to 3 significant digits. So this rounds off to 156 kilograms. Next up, we're converting from kilometers to miles. Write down what we're given. 450 kilometers. In my conversion factor chart, we have the number of kilometers compared to the number of miles. It says 1 mile is 1.609 kilometers. Cancel out kilometers. 450 divided by 1.609, we get significant digits now. What do we have here now? Here we have 4, here we have 2. Going to round this off to 2 significant digits. .450 kilometers is 280 miles. See now. 41 meters. We have to convert them to feet. We have that in our list. Meters on the bottom, feet on the top. It says here that 1 foot is 0.3048 meters. Meters cancel out. 41 divided by 0.3048. Round that off now. That's an exact number. 2 digits, 1, 2, 3, 4 digits. So I'm going to round this off to 2 significant digits. Now we want to go from days to years. 283 days. There's 365 days in 1 year. Units cancel out. I'm left with years here. Significant digits now. Exact number, exact number. 3 digits. So I'm going to round this off to 1, 2, 3 significant digits. This gives me 0.775 years. Next up, we have seconds to hours. We'll go from seconds to minutes. Then we'll go from minutes to hours. 1 minute is 60 seconds, and 1 hour is 60 minutes. Cancel units. I'm left with hours. 45 divided by 60 divided by 60, I get significant digits now. Exact, 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 exact. I'm dealing with 2 significant digits. 1, 2. So this will round off to 0.013 hours. Our last problem. This is combining rate. It's combining non-SI units. It's combining exponential values. It's a little bit of everything. So what's our game plan? We'll go from centimeters cubed to meters cubed to kilometers cubed, and then we'll go from hours to minutes. Make sure you cube those values. Hours is on the bottom, so it'll go on the top here. Minutes on the bottom there. 1 hour is 60 minutes. Cancel units out now. Centimeters cubed cancels centimeters cubed. Meters cubed cancels meters cubed. Hours cancel hours. I'm left with kilometers cubed divided by minutes. Right here. Combine those together. Divide that by 60. Gives me 0.75 times 10 to the minus 15 kilometers cubed per minute. Not proper scientific notation. 7.5 times 10. We're making this number bigger. So we have to multiply by 10, so we have to divide this one by 10, so this makes this smaller. Significant digits now. Exact number, exact number, exact number, exact number, exact number, exact number. 2 significant digits. There are 2 significant digits, therefore our final answer right here. 7.5 times 10 to the minus 16 kilometers cubed per minute. At this point in time, we've covered all the basics of conversion factors. We've gone over metric conversions, the SI units of conversion. We've gone over rate conversions, exponential conversions, density conversions, and non-SI unit conversions. In our next lectures, we're going to focus on chemistry, chemical conversions. We call that stoichiometry. Hopefully you've already taken this in your chemistry classes, and this should be review and hopefully solidify the understanding of stoichiometry in your mind, because you need to know this if you want to work in a lab. I'll tell you this, if you can't do stoichiometry, you better find another career. That's all for today. Until next time.